problem, we're given three rational equations, and we are asked to determine the horizontal asymptotes of each of them. To find horizontal asymptotes of rational functions, you always end up comparing the degree of the expression in the numerator to the degree of the expression in the denominator, which is quite the mouthful. So for the purpose of this video, I'm going to denote the degree in the numerator dn and the degree of the polynomial in the denominator as dd. So in this case, if you look at the highest exponent in this polynomial, it's a 1. So I would say that the degree of the numerator is equal to 1. And down here in the denominator, you see that the highest exponent is a 2. So we would say the degree of the denominator is 2. Well, since 1 is less than 2, we have the first case that the degree of the numerator is smaller than the expression in the denominator. And when that happens, it turns out that your graph will always have a horizontal asymptote of y equals 0. That is case 1. Case 2, you have just the reverse of that your degree in the numerator is a 2 and your degree in the denominator is a 1, and whenever the degree of the numerator is bigger than the degree of the denominator, it doesn't matter that it's a 2 and a 1, it could be a 20 and a 15. It doesn't matter as long as the degree of the numerator is bigger than the degree of the denominator, you will get no horizontal asymptote, for which case many instructors want you to write DNE for does not exist. The horizontal asymptote does not exist, you don't get one. Turns out you get something called a slant asymptote, but slant asymptotes aren't horizontal, so if you're asking me for a horizontal one, I would have to say it does not exist. Case 3 would be where the degree of the numerator is neither less than or bigger than. Happens to be the case that the degree in the numerator is equal to the degree in the denominator, and that's the case here. Because I have a linear expression in my numerator, it's degree 1. And my denominator is a linear expression, so the highest exponent is also a 1. So since 1 is equal to 1, the degree of the numerator is equal to the degree of the denominator. And what you always do is look at the leading coefficients. Since my line here is in descending order, meaning that I have the highest degree term before the constant, my leading coefficient would be in front. Probably this is where it's got its name, it's in the lead. And over here, my leading coefficient would be right in front because it's in descending order. In general, the leading coefficient is defined to be the number in front of the variable with the highest exponent. So for this example, the number in front of the variable with the highest exponent would be 5 and 2. And you are to form ratio of that leading coefficient in the numerator to the leading coefficient in the denominator there, and you get 5/2. In fact, what you get is the horizontal line y equals 5/2. And when I teach this sometimes in my class, because we often put things in descending order, it turns out that the answer to the question is sitting right here. I sometimes explain this to my students as being the thumb rule, that if the degrees are equal, that you can use the thumb rule, and then my students say, well, what the heck is the thumb rule? And the thumb rule is that if this is the problem on the test, and the degrees are indeed equal, right? This degree is equal to that degree. And again, it doesn't matter that they were both 1s. They could both be 5s. Or I care. As long as the degrees are the same, and you're in descending order, that puts your leading coefficients in front here. So the answer is sitting right here, meaning if you were to take your thumb on the test and just cover this up, there's my thumb, so I got the thumb rule, there's your thumb, and you're left with the answer. The answer is that this graph will have a horizontal asymptote of y equals 5/2. Just please remember that when you write y equals 5/2 and you write y equals 0, that we're talking about these being the equation for a horizontal line. This isn't just a y value, it is the equation for a horizontal line. In fact, if you went to your calculator and typed in y equals 0, you would see that that gives you a horizontal line through 0. And if you typed in y equals 5/2, you would see on your calculator a horizontal line being graphed, and that horizontal line would go through y equals 2.5 or 5/2.